Good morning. In the last class, we discussed about the switch statement and we practiced some of the examples on switch case statement. Up to now, we discussed the conditional statements. We will write a condition. If that condition is true, it executes some block of statements. Otherwise, it executes remaining statements in the conditional statements. Coming to the go to statement. Here, it is a unconditional statement. It executes the block of instructions or set of instructions without checking any condition. Unconditional statements. This control is transferred without checking any condition. If you observe if condition, first we write one condition. If that condition is true, it executes the if block. If that condition is false, it executes else part in the if else statement. Coming to the unconditional statements, it is without checking any condition, it directly jumps to the specified location, and that's why we call it as a unconditional statements. In C, it is done by using goto statement. The unconditional statements or execution is achieved in the C language by using the goto statement. In C++ also we will do by using goto statement. Now we will discuss goto statement. The goto statement is a jump statement. It directly jumps to the specified location without checking any condition. It is an unconditional jump statement. The goto statement can be used to jump from anywhere to anywhere within a program or function. All of you know the goto word. In MS Word or Excel, we use the goto to go specified page number or some word. We use this goto. The functionality you know very well. In the MS Excel, if you click on go to option, if you specify the page number or other section, we will specify that criteria and will enter that number. If you selected page number and entered particular page number, then automatically it scrolls to that page. In the same manner, here also the go to statement, it jumps to directly to the particular statement or block of statements and execute that block of statements and continue the execution. It is used in to jump from anywhere to anywhere, from beginning of the program to end of the program or middle of the program. You can jump from end of the program to top of the program also in this language. The goto statement can be used to jump from anywhere to anywhere within the program or a function. Goto statement passes the control to anywhere in the program. It passes the flow of execution from Whenever it occurs, go to statement, go to word, and some label is specified. Go to particular label, then it goes to directly jumps. The control will jumps to that the label specified beside the go to statement. It requires a label in order to identify the place where the branch is to be made. It directly jump, unconditional jump. Whenever go to statement occurred, go to statement reads the compiler, it jumps without checking any condition, any expression, evaluating the any expression. It jumps to the specified location. To identify the specified location, we will give one label to that block of statements to identify where to jump from here to go to, from here to where to go. If you say to the children go, then they will ask where to go, why should go, like that questions. In the same manner here also we are giving the instruction to the computer, go to, where to go, we must specify the address. For that address we will use the label. By using this label, the compiler identifies that label location and the control passes to the that particular location or that label. Label may be any valid identifier and must be followed by colon. So all of you know the label may be any valid identifier. All of you know identifier is a word. Identifier must be started with a alphabet. Identifier may contain numbers, doesn't accept the spaces in between the identifier. These are the some rules. Identifier is a label or name. We will give the identifier for the functions or data types, variables. While you are giving the identifier, while you are framing the identifier, these are the rules. Identifier must started with the alphabet, doesn't accept spaces, identifier may contain digits, it accepts underscore. The same rules you must follow while giving the label names in the goto statement. The label may be any valid identifier and must be followed by a colon. Now we'll see the syntax of goto statement. Here two syntax are there. If you observe, the syntaxes, two syntaxes are different. Go to, in the syntax one, go to label, that is the colon, go to label, semicolon is there, and label is the end of the program. Label with colon. Here in the syntax 2, label colon, the sum of the instructions, the dotted line indicates some of the instructions. After executing some of the instructions, you will find, we find go to label, semicolon. If you observe the syntax 1, the flow of execution while executing the program, if the syntax 1 has the first case, it the program will execute the go to statement. A label is there. Immediately the compiler passes the control to the label. It ignores the remaining instructions followed by the go to label statement. It executes the label instructions and follow the instructions after that label block. This is the thing in syntax 1. Syntax 1, once again, go to label semicolon. These dotted lines indicates some instructions of a program. After that instructions, label colon is there, label followed by some instructions. Okay. Whenever the compiler executes go to label instruction, the control passes directly. The control jumps to label and executes the instructions under the label. After executing that instructions, it is executing the remaining program. Here, the control is directly jumps to the label indicated after some instructions. It is ignoring the instructions. It is happened in the syntax 1. In syntax 2, label is there, it executes these instructions. After executing the instructions, the compiler executes the last instruction is go to label semicolon. Whenever the compiler executes this go to statement, immediately it search for the label where it is located. The label is located in the beginning of the program, top of the program. Immediately the compiler, the computer will process the control to label, and after process the control again it starts the execution of the instructions. It is happen. This is the syntax 2. In the above syntax, the first line tells the compiler to go to or jump to the statements marked as label. Here label is a user-defined identifier which indicates the target statement. The statement immediately followed after label is the destination statement. The label can also appear before the go to label statement in the above syntax. In the first syntax, go to appeared first, after that label is there. In the second syntax, first label is appeared, then go to statement is there. Now we will see the syntax, some flowchart of go to statement. One example. The program started with start, label 1 is there, statement 1. After executing the statement, go to label 3. Directly it comes to label 3 and executes the statement 3 and stop the end of the program. This is the one flowchart. As we see the syntax 1, first go to statement is there, after that label is there. After executing the go to statement, we find label. This is called forward jump. If you observe this program, main some of the instructions, after that we find the go to statement, go to XYZ label is there, directly the control process to the XYZ label. That is after the go to. So this is called forward jump. In the same manner, we have backward jump. In the forward jump, we are coming front from top to bottom. The flow of execution from top to bottom. In the backward jump, the flow of execution from bottom to top. Here main function is there, some of the instructions, label is there. After appearing the label, it finds the go to statement. Here go to XYZ. Whenever it executes this statement, again the control passes to backward and executes that label statements. This is the forward jump and this is the backward jump. The control passes to forward from top to bottom. It is called forward jump. The control passes to back from bottom to top. Then it is called backward jump. You remember these 2 points. Backward jump may put you in an infinite loop. So be careful with backward jump with the unconditional go to statement. The drawback here, if the backward jump you use, it may put you in an infinite loop. Infinite. Finite means specified number of times. Infinite, there is no number. It repeatedly executes the statements. It may cause your system may hang. Backward jump. Observe once again in the previous slide. What you are doing? We are executing the instructions, and at the end of the program, again there is a go to statement. That go to statement is going to top of the program. It executes the label and comes again to the go to. This process may be repeatedly executed, repeatedly done. It doesn't comes out of the go to. This is called infinity loop. It doesn't come because it is unconditional. First it executes the go to statement XYZ. It directly jumps to the XYZ location label. It executes the instructions. After executing the statement, again we will find the go to. Repeatedly the go to will execute, again we will jump to XYZ. We'll come back to go to and we'll go to the XYZ location. This process may continue. It is infinite. So be careful with the backward jump with unconditional go to statement. There must be a condition in backward jump which takes you out of the loop. There must be a condition in backward jump which takes you out of the loop. If you didn't use any condition in the backward jump, it may be infinite loop. If you use a condition, then you may come out of the loop. With help of the condition, we will come out of the loop in the backward jump. It is very important and it is very dangerous to your program, because if you ignored any condition while you are using the backward jump, the program will repeatedly execute. The system may hang. Now we will see how to find whether the given number is even or odd using go to statement. This is the algorithm. First we will read the number. If it is divisible by 2, go to xy, else go to yz. Here we are using two labels. One is the xy and yz, two labels. If in this program we are going to use if statement also, if else statement. This is the algorithm. Xy display even, if label yz display odd. This is the program. Hash include stdio.h, main int num. Observe this program. Declared one variable num. Printf enter any number. Scanf function is used to read the number and store that number in num variable. If num modulo by 2 equals to 0, we are using the go to statement, go to xy. If it is true, it jumps to go to xy. In the xy, what we return? The xy printf, it is even. Return statement is there. It returns. It comes out of the function, main function. If it is false, the entered number is not divisible with 2. If it is a 5, it is not divisible with 2. Then it checks the condition. It is not divisible with 2. It executes the else block. In the else block, go to statement is there, yz. It directly jumps to yz location. In the yz label, we wrote printf. It is odd. This is the program. Now we'll execute the same program in the compiler. Open the Turbo C++. Click on File menu, New, type the program. Hash include stdio.h. This is the standard input-output header file for including the input-output library files for your program. Main function, it is beginning of the C program, declaring a variable int num. Printf to interact with the user, we are using this printf control string. In this control string, I am writing enter any number. Our program is to find out the given number is even or odd by using the go to statement. \n for getting the new line, double quotes, this indicates the control string is ended. To store, read the number from the keyboard. We are using the scanf function. %d is the conversion character for reading the integer number, and we are giving the address of num to store the number fed by the user in num variable. If we will check by using the if else condition, if else statement, we are checking num modulo of modular operator modulo 2. The resultant, this is the expression, the resultant value, it returns the remainder num modulo by 2 is equals to 0. If it is true, go to xy. This is the label, semicolon. Now we will write if the control passes to xy, what should we do? If it is true, we will conclude that it is a even number. In the xy label, we will write xy label must be followed by colon printf it is even \n double quotes semicolon. Return keyword is used to come out of the function, main function, to return to main, returning nothing here. So if the condition is true, go to the xy location. In this xy location, printf, we are printing the data. After that, we are returning back to the main function. End of the main. If it is false, the entered number is not divisible with 2. Then we will write, if that condition is false, we will execute the else statement, else block, as we discussed in the last sessions. If else execution, in the else block we will write go to, this is the go to yz semicolon. Now we will write yz here. End of this yz colon followed by printf double quotes \n it is odd \n for getting new line semicolon. End of the program. This is the program to find the given number is even or odd by using the go to statement. We will save this program by giving the file name even.c, go to dot c program. Enter. Program was saved. Go to. We'll compile the program. There are no errors, only one warning. Ignore the warning. Press enter. Run the program. Run the program. enter a number 55. Now we will check the output screen. It is odd number. Yes, it is correct. It is working. Now we will run the program again and verify whether it is working correctly or not by alt run 58. It is a even number. Alt W user screen. Yes, it is even number. It is working correctly. This is the program to find out the given number is even or odd by using goto statement. Close this compiler. Alt F. Yes. Now I closed this one. We will see one more example how to use the goto statement. Now we will see one more example how to use the goto statement. This example is for forward jump. Now if you observe the jump, the goto statement is executing. Here goto is there, goto x5. Whenever the compiler executes this goto x5, immediately it comes forward the x5. After the goto x5 statement, x5 label is there. It is the forward jump. Now we will see the example for backward jump. How to execute the backward jump by using the a condition. If you doesn't use the conditional condition for that backward jump, it become a infinite loop. This is the backward jump example for the backward jump program. The program is to write a program which prints numbers from 1 to 10 using the goto statement. The program is main int n declared n variable equal initialized as 1, the label colon printf percentage %d comma n plus plus. If the condition is there, if n less than or equals to 10, go to label, otherwise it doesn't execute the goto statement. Here if you observe this program, the n value is 1. First time it executes the goto statement, the condition is true. It executes this statement only 10 times. After 10th iteration, the n value will become 11. It checks the condition n is equal to 11, 11 less than or equal to 10. The condition is false. It comes out of that if block. After that if statement, there are no instructions in the program, that is the curly braces is there. It is the end of the program. This is the program to backward jump. The output is 1 2 3 4 5 6 7 8 9 10. It prints the numbers from 1 to 10. Now we will execute the same program in the C compiler. minimize this file, open the Turbo C++, click on File menu, take New option, type the program hash include stdio.h main #stdio.h is used to include the standard input output header files for your program. Main is the beginning of the C program, declaring the variable int n is equal to declaring the n variable and assigning the value 1, initializing 1. Label, I given the label colon. Printf, printf \n %d double quotes comma n semicolon. N plus plus incrementing the n value by using the post increment operator. We discussed this also. If n less than or equals to 10, go to label L semicolon. This is the simple program to print the 1 to 10 numbers. Now we'll save this program. Save, go to .c, run the compile the program. Yes, there are no errors with only one warning. Ignore this warning because we are getting this warning because every function will return something. Your main function is there. Regarding that, function should return a value. It is showing function should return a value. Now run the program. Run. Program is run. We will see the output. Alt window, user screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These numbers are printed. This is the program. Here we are using the backward jump. First label is there. After the label we have the go to statement. Here we are using one condition. If under the if block we wrote go to label. Here the meaning of this one, here we have only one statement. That's why I didn't use this curly braces. Actually this go to label is we wrote inside the if block. That's why the condition is checked and it is printing the numbers. Now we will change the condition. We will write the condition only 5. Now we will check. Don't use this slash n, then it will print on line. Run, compile the program. Run the program. See the output. User screen. 1, 2, 3, 4, 5. The 10 is previous one. This is the program. If you doesn't use the backward slash this condition in this program, what happened? We will see that one also. We will remove these two statements. If statement, if you execute this program like this, it will struck your, it hang the program. The program will become a infinite loop, because first it executes these first instructions. After it finds the go to label, it goes to repeatedly it executes these statements. We will see once what happened. Alt C, compile, there are no errors, run the program, Alt R. This is the thing, it is happened. The system, it is repeatedly executing, printing the numbers 1 2 3 up to infinite, end of the numbers. So it may hang your system. This is happened. For that we have to escape. Up to now we saw how to write a program by using the go to statement with forward jump and backward jump. These two examples we practice, and in the backward jump, if you ignore, if you forgot the conditional statement, it becomes the infinity loop. That is also we saw in the compiler while we are executing that program. Now we will see the disadvantages of using go to statement. The disadvantages, the use of go to statement is highly discouraged as it makes the program logic very complex. The usage of the go to statement, it is difficult, it is complex. If I want to execute 10 times that statements again and again, we will not write the go to 10 times. Use of go to makes the task of analyzing and verifying the correctness of programs, particularly those involving loops, very difficult. If you write this go to statement in the loops, it is very difficult to analyze the go to statement, how the program executing, the flow of execution. It is very difficult to analyze the program execution. Use of go to can be simply avoided using break and continue statements. As we discussed in the switch statement, break statement is used, break instruction. Break instruction, whenever you use this, whenever it executed by the compiler, it comes out of the switch statement. For each case, we write break instruction. Whenever it executes the break statement, it comes out of the switch statement after executing the matched case. And in the same manner, continue statement is also used to continue the loop or statements. Again, we use the continue, but it ignores the followed instructions. The continue statement, it continues the flow of execution again, but it ignores the remaining followed instructions. These two statements, break and continue statement, is discussed in the next class. In this class, we discuss the unconditional jumps, unconditional statements. The unconditional statement is in C, go to. Unconditional means without checking any condition, it jumps to the location, jumps to some other part of the program. The flow of control is directly jumps transfer to other location in the program. The unconditional statements in the C language is go to. By using the go to, we achieve this unconditional jump. The go to we use two ways, that is the forward and backward jumps. Forward jump and backward jump. While you are using the backward jump, you must remember it may become a infinite loop. So for that, you must use the condition. This is the very important thing. These are the two programs we practiced by how to print the even or odd number by using the go to statement, and next one is the printing the 1 to 10 numbers by using the go to statement. This is the summary.